Hi, everybody. I wanted to spend a little time going through pre-lab 3 regression analysis. You're asked in this pre-lab to download a script, which you should download and then open up in RStudio. And then we'll go through the code line by line. And let's get it up here. There we go. And we'll run the code and see what happens, right? Explain each individual line. This is how you'll learn how to use R. So this code will eventually get us to a regression analysis. So we have a bunch of hashtagged comments at the top of the code, and then we have our command that clears the working space. I'm going to just hit Command Enter. Notice when I hit Command Enter or Control Enter, depending on whether you're Mac or Windows, the cursor goes down one line to the next line. Every time you hit Command Enter, RStudio will ignore comments and go down to the next command. So when I hit Command Enter again, it goes down to the library command, loads the first library, second library, third library, fourth library. Then we'll turn off scientific notation. And so that's our preliminary set of options that we have here. In this script, we don't need to set a working directory because we're going to be reading in data from the internet. So we're not going to look on our local computer on your laptop. We're not going to look for data there to read into R. Instead, we're going to get it from the internet. So we don't need a folder directory for this. Let's see. So here's what we're going to do. To get the data, we're going to go to the World Bank's World Development Indicators. It's a database of data about every country in the world. We're going to get these 10 or so variables. The variables, they have hundreds of variables, and so each variable has a kind of complex name. But we have hashtagged here, very helpfully, what the variable is. And the unit of analysis here, the entity of analysis, are countries. So the first thing we do is we create a list of the variables that we want. So that's now in our environment. We can see over here, WDI list is the list of these variables. So the command to make this list or vector is just C. So that's the simplest command in R. C creates a vector. So I have a vector of these variable names. It's a character vector. Our next command is going to be to go to the World Bank Development Indicators website, which is what this command WDI capitals will do. It will get all of the indicators in WDI list, which we just created right here, and we'll get the values of those variables for 2020, starting in 2020 to 2020. Remember, in this class, we're only going to do cross-sectional data. If we wanted more years, so if we had 1960 to 2020, we'd have many observations for each country. That would be panel data, a cross-section with time series. But we're only going to look at cross-sectional data here. So we'll just get 1 year, start at 2020, end at 2020. So I'll go and read this. It will take a few minutes for the to be connected to the internet. So it'll go to the World Bank Development Indicator server, retrieve the values for 2020. What we're going to do next, once the data is in here, it'll show up. It takes a couple minutes to show up. We need to wait a second. There it is. So we can see now in our environment that we have WDIM there. We can click on the blue button and it tells us, oh, here's the variables that we wanted. But these are complex names for the variables. The next command that we can run, this rename command, will change the names of the variables. So the syntax here is we take WDIM, the name of our data frame, we pipe it into the rename command, we rename all of these, and then we assign it back to WDIM. So that's how you'd read this command. We take WDIM, we pipe it into the rename command, and we assign it back. This is the assignment operator here, right here. So we assign it back to WDIM. So WDIM here, our data frame, now has names that are more easy to understand. We're going to take out, right, notice that right now we have 266 observations. We're going to take out observations that aren't countries. So the exclamation sign here means not. So we're going to subset the data to not have regions equals aggregates. So we're only going to have regions where it gives the region and hence it's a country rather than these aggregated ones. You can look at the data set yourself and explore what that means. And then we're going to use this piping syntax again to change GDP to divide it by 1,000. So the GDP, real GDP per capita will be in thousands of dollars. So we run that. Notice here's real GDP per capita right there. It's 1968, 13,278. Look what happens when we run this command. We created a new variable down here, 1.97, 13.28. So everything got divided by 1,000. Pretty straightforward. Now we're going to run a table of descriptive statistics. So we'll use the data summary command, which is in the model summary package. So we loaded the model summary package up here. Right here is where we loaded model summary. And then we use the command data summary, which is the command in that package, to create a table. And we have the table over in our viewer window. So here's our viewer tab. Here's our table. Mean GDP per capita is $20,000. Mean life expectancy is 72 years. Life expectancy for females a little higher, 75 years. Life expectancy for males a little lower, 69 years. Now we're going to run two regressions. So we're going to run life expectancy as the outcome variable and GDP as the explanatory variable. So we run the first regression, we run the second regression. So we have two regressions that we ran. We put them into a list called models, and then we use the model summary command to display the results of our regression, our estimated coefficients. Here's our intercept, beta 0 hat. Here's our slope coefficient, beta 1 hat. We have two separate regressions. So we did two separate regressions. We display them in a table. Each regression is displayed in a column. So this is one regression, 188 observations. Our R square is 0.54. Here's a second regression. Also 188 observations. Our R square for this one is 0.51. How do we interpret these coefficients? Well, for every $1,000 increase in GDP, a 1 unit increase in this variable is 1,000 extra dollars. For every $1,000 in GDP, life expectancy goes up by 0.26, by a quarter of a year. So on average, for each $1,000 increase in GDP in a country, life expectancy goes up by a quarter of a year. So if GDP increased by $10,000, so we went from a country with $20,000 GDP to $30,000 GDP, $10,000 increase, life expectancy would go up by 2.68 years. So we'd multiplied by 10, right? So that's the result of running some regressions and interpreting them.